Okay, so this is Unit 7, Solutions, and this is Lesson 1. As you'll see, there's a whole bunch of new vocabulary that we're going to learn in this lesson. It is important that you understand what each of these words mean, as they may be tested on the Regents exam. So, what do we plan to cover today? Today we will review, because you already should know, the difference between a heterogeneous and homogeneous mixture. We are going to talk about various types of heterogeneous mixtures and their properties, including colloids and suspensions, and identify the various types of homogeneous mixtures and their properties, including alloys and solutions. We are going to define solubility and understand the factors that contribute to solubility. Nature of the solute and solvent. We'll review like dissolves like. We've talked about that before. Temperature. And I don't know that we'll get to Table F today to determine if a precipitate is formed, but we have used that before, and we'll review that. So you should have out your note packet. Let's get started. A mixture is a combination of two or more pure substances, meaning elements and/or compounds that can be separated by physical means. Now, when I talk about physical means, let's take a minute and review. Some examples of separation by physical means could be distillation. Distillation is the separation of a mixture based on boiling point. It could also be through filtration, where you have two substances of different particle size. You can run it through filter paper, and one will get trapped and the other will run through. It could be by decanting. And when we say decanting, that's simply another way of saying pouring off. So let's say I have two substances that have different densities. And I want to separate them, I could put them in the same flask and let them separate and then pour off the substance with the lighter density. And another is, and we talked about this in another unit, is chromatography. And you did that in biology, where you separate a mixture based on the polarity and the size of the molecules in the substance. Okay, mixtures can be categorized into one of two groups. First, we have a heterogeneous mixture, which is a mixture of two or more pure substances in different physical states. Meaning it has varying composition. It's not uniform throughout. Some examples of these could be rice and sand, it could be sand and water, and my favorite, chocolate chip cookie dough. Remember, we're not always guaranteed to get the same number of chips in each spoon, so it's not uniform throughout. Okay. A suspension is a heterogeneous homogeneous mixture that clearly separates. So here, if I shook this bottle up, it was a mixture of water, clay, and sand. Eventually it separates upon standing. The solid does not visibly dissolve in the liquid or break down. You can also separate by filtration using a filter. And this is for relatively large particle size. And I listed some examples of already, but we can just list sand and water again here. Okay, a colloid. A colloid is a heterogeneous mixture that does not clearly separate. It's cloudy. It appears homogeneous, okay, but it really isn't. It does not settle naturally on their own through time. It can be separated by a centrifuge. And I have one of these in the back of the room, which spins the substance at such a high speed that the particles separate due to gravity. Medium to small particle size. They're not a suspension because they don't separate out on their own, and they're not a solution because they're not completely clear. A good example of this would be blood and milk. And then we have a homogeneous mixture, aka solution. Meaning homo, the prefix meaning same throughout or consistent throughout. It's a mixture of two or more pure substances in the same physical state. It looks like a clear, colored, or colorless beaker of water. It looks like clear, colored, or colorless water. It has extremely small particle size. To the point where you can't see them. And it can exist in any phase, but liquid is the most common. So some examples of this are salt water. You've seen me dissolve salt and water in class. Kool-Aid. And even club soda. When a light source is off, we can tell that the last one is a suspension because you can actually see the particles in it. Now when we turn the light source on, we can see that the second one is a colloid. And the reason being because you can actually see the beam of light in the beaker as the light passes through it. If you shine a light source through a solution, you will not see anything. If you see particles within the solution, then you know that it is a suspension. If you can see the beam of light pass through it, then you know you have a colloid. And if you can't see anything, then you know you have a solution. Okay, let's move on to an alloy. An alloy is a solution where at least one of the materials is a metal. Although most times it is a mixture of two or more metals. Metals arrange in an alternating pattern with a sea of mobile electrons. You've heard that before. Gluing them together. We have an example of brass, which is made up of copper and zinc. And we also have an example of steel, which is made up of carbon and iron. Now, I'm going to explain the two. You really don't have to know the difference between a substitutional alloy and an interstitial alloy till we get to the next level, but I do want to explain the two. Let's start with steel. Steel is what's called an interstitial alloy, and that's because it's got other elements in the spaces between the molecules. So you have all these iron atoms here, and the iron atoms are pretty big, and then you have these small spaces in between, and then iron fits right nicely into those small spaces. So that's called an interstitial alloy, which is different from a substitutional alloy. A substitutional alloy sounds exactly like a substitutional alloy is exactly what it sounds like. You're substituting carbon for some of the, you're substituting copper, you're substituting zinc in this case for some of the spots that normally would be completely copper. So if we take out a copper atom, replace it with a zinc. Take out another copper atom, replace it with a zinc. So brass is considered a substitutional alloy. And you have these examples listed here, but you have brass, which is the copper and zinc. You have steel, and then bronze. You may have heard of bronze. That's another example of an alloy. Okay, let's move on to solutions, because that's what we're going to focus most of our time on. They're homogeneous in nature, right? Meaning that they are consistent throughout. They are clear as opposed to cloudy, and do not disperse light, meaning no Tyndall observed. Well, what is Tyndall? Tyndall effect.